And next one is event listeners. Event listeners. The listeners that handle events are called event listeners. First, listeners are registered. Second, it must be implement various methods to receive and handle events. So, listener registered. Then second one is implement various methods to receive and handle the events. There are different types of event listeners interfaces. First one, action listener interface. Definition. This interface defines the action performed method that is called when an action event occurs. When an action event occurs. So when an action event occurs, when an action event occurs, then listener, action performed method is going to be called. Okay. General form, void space action performed a small peak caps, then within brackets action event. AE. Then adjustment listener interface definition. This interface defines the adjustment value changed. Okay, method that is called when an adjustment event occurs. So general form is void space adjustment value changed adjustment event AE. Adjustment event AE. Next, third one. Third one is component listener interface. Component listener interface. Definition. This interface defines four methods that are called when a component is resized, moved, shown, or hidden. Void component resized one, component event. Void component moved, second one. Void component shown, third one. Void component hidden, fourth one. Similarly, this is component resized, there is no space, and component is C small letter, first letter, then resized R is capital letter. No space, remember. Okay, similarly component event also like that, but in component event all are predefined classes, so C and E are both are capital letters. Okay, now fourth one, container listener interface. Fourth one is container listener interface. In container listener interface definition, this interface defines two methods that are called when a component is added or removed from container. Void component added, void component removed. The classes, predefined classes are container event, and second one also container event. Now focus listener interface. This interface defines two methods that are called when a component is obtains or losses keyboard focus. Keyboard focus, if it is obtained or keyboard focus is going to be losses, then this method is going to be called. So here general form is void focus gained and void focus lost. So within brackets focus event FE, focus event FE. Then item listener interface. This interface defines item state changed method that is called when the state of an item changes. General form is void space item state changed. I is small, S state S is caps, changed C is caps. Within brackets item event I. Then key listener interface. Next one is key listener interface. In key listener interface, this interface defines three methods. That is the key pressed, K small letter, P capital letter. Key released, K small letter or capital letter. Methods are called when a key is pressed and released respectively. The key typed method is called when a character has been entered. General forms, void key pressed, key small letter K, P, K small letter in first letter, in key first letter K is small letter, all are small letters. In pressed P is caps, only P is caps, then there is no space. Similarly, void key released, key event K, void key typed, key event K. Then mouse listener interface, that is mouse dragging and moving. Mouse listener interface. So this interface defines five methods. If the mouse is pressed, released at the same point, mouse is clicked and mouse enters and mouse exit, okay, leaves, okay. So these are the different methods. This interface has defined five methods. If the mouse is pressed and released at the same point, mouse clicked is called, mouse enters a component, mouse leaves, that is mouse exited is called, mouse pressed and mouse released methods are called when the mouse is pressed and released respectively. Now in this case, what are the different general forms? Void mouse clicked, void mouse entered, void mouse exited, void mouse pressed, void mouse released. Void space, mouse clicked, M is small, C is capital, then no space. Void space, mouse entered, that is mouse M small, E caps. Then void space, mouse exited, that is M small, E caps, no space. Void mouse pressed, M small, P caps, no space. Void mouse released, that is M small, R caps, no space. So within bracket mouse event. Mouse motion listener interface. Mouse motion listener interface. Here this interface defines two methods, that is the mouse dragged, press and dragged method is called multiple times as the mouse is dragged. The mouse moved method is called when multiple times as the mouse moved. General forms: void mouse dragged, mouse event ME. Void mouse moved, mouse event ME. Then 10th one, that is mouse wheel listener interface. Mouse wheel listener interface. This interface defines the mouse wheel moved method. The mouse wheel moved method. M small letter, MOS, all are small letters. Wheel W, caps, M caps, moved M caps. No space in between mouse wheel moved. So the interface defines the mouse wheel moved method, that is called when the mouse wheel is moved. General form: void mouse wheel moved mouse wheel event MW. Here just you can write the spaces and you write about the comment, whatever you write about the text inside. Then text listener interface. Text listener interface definition. This interface defines the text value changed. T small letter, value of V capital letter in changed C capital letter. Method that is called when a change occurs in a text area or text field. So general form is void text value changed within bracket text event. Next, window focus listener interface. 12th one, window focus listener interface. This interface defines two methods, that is window gain focus, window lost focus. These are called when a window gains or losses about the input focus. Then general form, void window gained focus, window event MW. Void window lost focus, window event WE. Then window listener interface definition. This interface defines 7 methods. Window activated, window deactivated. Methods are called when a window is activated or deactivated respectively. If a window is iconified, then the window iconified and the window iconified and the window iconified method is called. When a window is de-iconified, 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 the window iconified method is called. When a method is de-iconified, when a method is de-iconified, when a method is de-iconified or when a window is de-iconified, the window de-iconified method is called. When a window is opened or closed, the window opened or window closed methods are called respectively. The window closing method is called when a window is being closed. Then general forms: void window activated, window event W. Void window deactivated, window event W. Void window opened W. Void window closed, window event W. Void window closing, window event W. Void window iconified, window event W. And void window de-iconified, window event W. In this void space, all are void space only, but window activated means window all are small letters, in activated only A is capital letter, remaining are small letter. Remember this: window activated, window deactivated, window opened, window closed, window closing, window iconified, window de-iconified. There is no space in between window and de-iconified, etc. Now handling mouse events. Now how to handle about the mouse events program. The mouse listener interface defines 5 methods. The mouse motion listener interface defines 2 methods. So a mouse event is generated by a mouse. There are 8 types of mouse events. There are 8 types of mouse events. There are mainly 3 methods are used. That is get X, get Y. Get X, get Y. There are mainly 3 methods are used. One is get X, get Y, get point. Okay, get point. Get X and get Y return the X and Y coordinates of the mouse when event occurred. Get point is used to obtain the coordinates of the mouse. Program demonstration on creation of mouse events. First one, import java.awt.star, import java.awt.event.star, import java.applet.star. First, write about the comment, that is applet code equal to mouse event demo width equal to 500, height equal to 500, applet end. Public class mouse event demo extends applet, but implements what are the mouse listener and also comma mouse motion listener. String s1 equal to null into x comma y, public void in it. First, register about the listener interfaces. Add mouse listener this, add mouse motion listener this. Now you write different methods. Public void mouse clicked, that is x value y value is given. S1 is mouse clicked, repaint, call about the paint function. So public void mouse entered, mouse event me. Here you given about x value and y value. S1 is mouse entered, then repaint, that means call about the paint method to display. Public void mouse exited. So x equal to 100, y equal to 300. Now s1 equal to mouse exited given, repaint. Similarly, public void mouse pressed, x equal to me dot get x, y equal to me dot get y. And s1 equal to, you write mouse pressed, repaint. Public void mouse released, x equal to me dot get x, y equal to me dot get y. S1 equal to mouse released, repaint. Public void, next public void mouse moved, that is x equal to get x, y equal to get y. S1 equal to mouse moved, repaint. Then public void mouse dragged, mouse event. So x equal to me dot get x, y equal to me dot get y. S1 equal to mouse dragged, repainted. Similarly, now public void paint graphics g dot draw string s1 comma x comma y. So that xy position is going to be display about the s1. Similarly, handling keyboard events. Similarly, handling keyboard events. The key event class defines three types of events. The key listener interface defines three methods. The most commonly used methods in this key event classes are char get char and int get key code. Char get char, this returns the character that was entered. Int get key code, this returns key code. Now program demonstration on creation of keyboard events. First, import java.awt, import java.awt.event, import java.applet. Now you write about the comment applet code equal to keyboard key event demo, width equal to 500, height equal to 500, applet end. Public class key event demo extends applet, implements key listener. Implements key listener. String s1 equal to null into x comma y, public void in it. So you have to register to add key listener this and request focus. Now public void key pressed, x equal to 100, y equal to 100, then s1 equal to key pressed. Then next x equal to 100, y equal to 300, s1 equal to key released. It's going to be display. It is display. Public void key typed. So read, how can read s1 equal to s1 plus ke dot get key char. Get key char. You can easily get it and call the paint function. Public void paint graphics g. So just display compulsorily today. You can display about this one. You can display g dot draw string s1 comma x comma y. So s1 comma x comma y. Then a program handling on window events. Next one is window events. Import java.awt.star, import java.awt.event.star. Public class window demo extends frame, implements window listener, because this window listener cannot going to be I mean, we cannot use about the applets. There are something we cannot use in applets. There are many things using the applets. String s1 equal to null, int x equal 0, y equal 0. That is nothing but origin value. Public window demo. So which one you have to register? Add window listener. So this is going to be registered. Now public void window activated. X equal to 100, y equal to 100. It display about the window activated. Then next public void window deactivated. So x equal to 100, y equal to 150, s1 equal to window deactivated. Similarly, public void window opened, window event, x equal to 100, y equal to 200, window is opened, display. Then public void window closed, x equal to 100 and y equal to 250, s1 equal to window closed. Repaint means you can call the paint function. Now public void window closing, in that case x equal to 100, y equal to 300. S1 equal to window closing repaint. Then public void window iconified window event w x equal to 100 y equal to 350 s1 equal to window iconified repaint public void window deiconified window event w x equal to 100 y equal to 400 s1 equal to window deiconified repaint. Now public void paint graphics g, so you can display g dot draw string s1 comma s comma x comma y. Now where you can execute this, you can execute in public static void main string arguments. So public static void main now string args. So first create about the object window demo. Window demo w equal to new window demo. Now set the size w dot set size 400 comma 400. W dot set visible true. So automatically it's going to be display the screen. Now adapter class. Next one is adapter class. An adapter class provides an empty implementation of all methods in an event listener interface. Adapter classes are useful when we want to receive and process only some of the events. For example, mouse adapter has 5 methods. The signatures are same that of mouse listener interface methods. If you interest only mouse clicked event, then we can simply extend mouse adapter class and implement mouse clicked method. For every listener, there is an adapter class. Remember. So normally we have to suppose if you have 7 methods or 5 methods are there in case of mouse events, so you have to write all the methods compulsory. Okay, but if you use the adapter class, particular adapter class of the particular one, okay, then no need to no need about the, okay, no need about implementing all methods. Just whatever you want you can implement. That is the advantage of adapter. Then program demonstrates on adapter classes, that is import java.awt, import java.awt.event.star, import java.applet. Applet code equal to adapter demo, width is 450, height is 300, applet end. Public class adapter demo extends applet. Now you write about the s1 equal to null xy, public void init register, add mouse listener. Then in this you write about the a, new a this public void paint graphics g dot draw string s1 comma x comma y. Now you write class a extends, because of here there is no applet, so you can write about, no need to write about the public. Class a extends mouse adapter demo a1. So public a adapter demo a, now a1 equal to a here. If it is a, then you can write here this dot a equal to a. Now next public void mouse clicked. You can write only one method. Okay, I am not writing all the methods. Mouse clicked, then mouse event me a1 dot x equal to 100, a1 dot, because we have to refer about the through a1 dot y equal to 100, a1 dot s1 equal to mouse clicked, a1 dot repaint. Now inner class, last one is inner class. A class inside another class is called nested class normally. A nested class can access the members and private members of the outer class. The nested classes can be two types, static or non-static. A static nested class can access only static members and without creating object in outer class. We cannot call the inner class members. So these static nested classes are rarely used. So non-static nested classes only used, it is called as a inner class. So example program, that is nothing but class A into L equal to B. Now write about the class B, take about one more variable into B equal to 200. Now void display, how you can print system.out.println L, because L equal 100 is only in class A, but B equal to 100 is in class B. That's why B1 equal to new B. Create object. Through object reference only you can call system.out.println B1.b. Now class inner demo. Public static void main string arguments. First create object for A1 equal to new A. Finally you write about the A1 dot display. It's going to be called the display function and it's going to be display the contents. Display the contents. Okay, display the contents. This is going to be completed about the 5 unit 5 of Java program, unit 5 of Java program.